Alright, this is section 2.8, which is about absolute value functions. So we're going to talk all about the absolute value functions and how to graph them. So first, the absolute value functions, all of them are V-shaped. And have symmetry. The vertex is the most important part. So they're all V-shaped. So for example, this could be a graph of the absolute value function. And this point in the middle here is our vertex. And as you can see, it has a line of symmetry through the vertex. So here's one example of an absolute value function, but it could be the other direction. So opening down here. And again, it has a line of symmetry through its vertex here. It also could be opening to the right here, and now its line of symmetry is here, and then again it could open to the left. And depending on the equation, the absolute value function can be a more skinny V or a wider V. But here are just some quick examples of what the absolute value functions look like. So the simple form of the absolute value function is just y equals the absolute value of x. So absolute value are these straight brackets there. And again, this graph will look like, the simple form will look like just facing up like a normal V, and it will have a line of symmetry right through the vertex, like we just talked about. Now the absolute value function can be looked at as a piecewise function, where the function is just f of x equals x if x is greater than or equal to 0. Right? So if you put a positive number into the absolute value function, it just comes out the exact same. However, if you put a negative number in, so if x is less than 0, then we tack on a negative. So think about if we are taking the absolute value of -3, technically we're taking the opposite of -3. And we know the opposite of -3, that'll give us a positive. So here's that piecewise function, which we've been talking all about. So our first example here is to graph the absolute value function from above. So just like we've been doing here, we're going to have a closed and an open point. Another color here. So this will be the closed and this will be our open. But we notice that we get, for both of our points, just 0, 0. So that's this middle point here. Plot that, 0, 0. And now next, to the right of 0, my function is just y equals x. So you could think about that. We have a slope of 1, right? So we're going up 1, over 1 here. So here is that side of it. And now the left side, like we said, we always have symmetry through the vertex. So really, the absolute value function in the simple form here has symmetry about x equals 0, that vertical line here, that's going to be its line of symmetry. So it has to go off to the left side here. Should be perfect symmetry there. And we refer to this side as the right branch, and this side as our left branch. Just so you know, and that's pretty easy to remember. Left branch, right branch. So that was the simple form of our absolute value function, but things can get a little more fun. So this is the standard form of our absolute value function. So now, instead of just having y equals the absolute value of x, we now have a, h, and k in the mix. So how do a, h, and k change the look and position of the graph? Well, first, hk is the vertex. So in that first example, 0, 0 was our vertex, which is why we didn't have an h or a k. But sometimes the vertex might change, so hk will always be your vertex, which means the absolute value function will always have x equals h is the line of symmetry. And then a is actually the slope of the right branch. So remember I said that if the absolute value looks like either this or this would be our right branch, this would be our right branch. So A is the slope of those lines. And we also talked about absolute value functions that look like this and this, but we won't work with graphing them too much yet, but we'll get to that later in the topic. So to graph the absolute value function, here are our steps. So the first thing you want to do is plot the vertex, which is again always hk. And then your next step, you could either plug in any value for x. So plug it into your function to find y, your output, and then plot this point. So plot that point on your graph. And then since from there, we'll go to the third step here, you can always plot a third point because it will be symmetrical to the second point. So you're using that symmetry to find your third point. And from there, you can connect and extend using a straight edge into that classic V shape that we know all of our absolute value functions look like. However, if you prefer, you also, instead of plugging in a value for x, you could apply the slope of the right branch because we know that value is a. So you could just use the slope to find your second point and then go on to steps 3 and 4. And I'll do it both ways in the next example. So I think it'll make a little bit more sense then. So, example 2 here, we're going to graph this absolute value function. So our first step is to plot the vertex. Remember, my vertex is hk, and my standard form of my equation is this. So because my standard form is x minus h, but here it says x plus 1, I really have x minus a negative 1 in there. So my vertex hk is negative 1, and then my k is negative 4. That will be my vertex. So a quick way to think about this is your h will always be the opposite of what you have going on in your absolute value, and your k is always just at the end, whatever you have at the end. Make sure you take the opposite of what's in here though. So there's my vertex, so we're going to plot that. Negative 1 minus 4 there. And then remember for step 2, I have 2 options. So I could either pick a value for x and put that in there. So I'm going to pick 0, because that's pretty easy. So let's say x equals 0. So when x is 0, I get y equals minus 2, the absolute value of 1, minus 4. Well, this is just minus 2 minus 4, which gives me a negative 6. So I need to plot the point 0, negative 6. So 0, negative 6. However, I could also look at A. My value of A is negative 2. So A is negative 2. And remember, my value of A is the slope on my right branch. So I'll do the step in green here. I could have looked at my vertex here and said, hey, my slope is negative 2. So that means go down 2 over 1. And I would have got the same point. So whichever method you like better, you'll get the same graph here. So there's my right branch. Remember, the third step is to just use symmetry. I'll do the step in blue to get your third point. So here was my second point. Remember the line of symmetry through the vertex. Well, symmetrical point would have been over here. So there's my left branch. So then step 3 was to plot third point. And then step 4 is just to connect the V and make sure you add arrows. So that would be your final graph there in blue. So now we did some graphing. So this example wants us to write the equation for the absolute value function with a vertex of 2, negative 3, and passing through the point 3, 0. So I'm going to plot this. So 2, negative 3 is my vertex, and it's passing through the point 3, 0. So this point here. So my vertex is 2, negative 3. So my H is 2. My K is negative 3. We'll see here, isn't this just the right branch of my graph? And I know A is slope of the right branch. So now we just need to solve for the slope of this line. Well, passes through the points 2, negative 3, and 3, 0. We know my slope is just looking at my y minus my y, rise over run, and x minus x. So I get negative 3 minus 0, 2 minus 3. That gives me a negative 3 over a negative 1. Gives me a positive 3. You could also look on your graph here, look at from your vertex, and count your rise, be 1, 2, 3, and then over 1, 2, 3, 4, 5. Alright, so looks like we made a little mistake there, which is always good to check our work. So I plotted negative 2, negative 3, but our vertex is 2, negative 3. So 2, down 3. And then passing through the point 3, 0. So there we go. So our slope is 3, and then this way I see we're going up 3 and over 1. So there our A's match. So make sure your graph looks like that. Don't make the graphing mistake I did. So our A is 3, which we found through, you can either find the slope there, just look on the graph. It's probably easier to look on the graph. So now my final equation is just y equals 3 x minus 2 minus 3.